before we go ahead and we understand how to implement real-time intelligence in Fabric, let's understand what exactly is Fabric, right? Why do we need Fabric? What is the purpose of introducing Fabric? Because we all know that in today's technological world, we have so many tools that help us perform data analysis, right? If I just speak about one cloud, that is Microsoft Azure, or I speak about any other vendor also for that matter, whether it's AWS, GCP, or any other organization, they all have their tools that help us cater or help us build an analytical solution. Then why did Microsoft feel that, okay, I need another service, another tool wherein we can or wherein analysis can be done, right? So let's understand the purpose behind Fabric. Just give me a minute, everyone. So over here, like I said, we will be looking at how yeah, so I'm just sharing my screen. Just give me a minute. It's loading. Yeah. So over here, like I said, we have so many vendors, so many services out in the market that help us to perform analysis, right? Then why one more service Microsoft thought, which they introduced, which can help in the analysis. So let's understand that over here. So what is the problem exactly? Right? What is the challenge? What is the problem that such a tool had to be introduced in the market? Let's understand that first, right? Now, let's consider now we all know when we talk about analysis with data and data without analysis is meaningless, right? Any analysis that we are doing, we require data for it, right? If I have to analyze marketing data, sales data, whatever I want to analyze, we need to collect the data. Now, what happens because of that is also now when we are analyzing such data, we all know that it's not a one person job, right? There are so many people involved in helping us do the analysis. For example, we have a data engineer, right? We have a data scientist, we have a data analyst who have respective jobs, and we all know even companies also out in the market hire accordingly, right? For a role of a data engineer, they are very specific about it, correct? So over here, what happens now when a data engineer is working? Okay, for a data engineer, now there are many tools in the market. For example, if I just consider, I'm so sorry, let me just consider Azure Cloud. Okay, let's take one of the existing tools, that is Azure, where we can, of course, perform data and analysis, right? So on Azure Cloud, if a data engineer is working, so he will probably use Data Factory, Azure Data Factory, will probably use Azure Databricks, will use Azure Synapse Analytics, right? There are so many different tools that the data engineer has. Not just that, there are on-premise tools also like SSIS, like and etc. Many such tools that a data engineer can use. And likewise, you also find these tools on AWS or GCP or on Snowflake and etc., which a data engineer can use. So what is the job of a data engineer? Is to primarily clean and transform the data, correct? To make sure that whatever data we are getting from the different sources, it could be a database, it could be a data warehouse, it could be any source. So from whichever source they are getting the data, it is perfect, it is cleaned, it is transformed, so that when they do the further analysis, there is no error in the data, right? That is the job of a data engineer. So in order to do that, of course, they will use different tools. Like I mentioned, we have so many tools in the market. Now, the basic role of the data engineer is to clean, transform. Now, once that cleaning and transformation is done, it is passed on or it is taken care. The next part of the analysis is taken care by the data analyst or the data scientist. So now if a data analyst has to work, so what is the role of a data analyst? A data analyst will probably use tools like Power BI, Tableau, Click, something that helps in visualizing the data. So anyone who analyzes the data using visuals, basically create a report, create a dashboard, that is a data analyst. And a data analyst will basically use such tools. Now, after the data is cleaned and transformed, then only the analysis will be furthered, right? The data analyst will only then go ahead and build the report or create the dashboard. Without that, they don't do any, without this, nothing is done. Why? Because there will be errors and there will be missing values, which can affect the analysis, which will give us incorrect results. And we don't want that, right? We don't want the errors to come in the actual data. So what does a data engineer do? The data engineer will clean and transform the data and will load the data in another storage. So probably it could be a data lake or a data warehouse. That is what is commonly used in the industries also. Will probably use these tools and load the data there. Then the data analyst will pick up the data from there and create reports, create dashboards, use other tools to do that. Correct? Now, even the scientist can come. Now, if I want to do training of an AI model, now AI is also in a way we are doing analysis. So, what is that analysis called as? It is called as a predictive analysis. So, if I want to predict the outcome, we need data for that again. So, it's a analysis only that we are doing. We are inferring from the data and we are predicting the outcome. Now, if the data scientist has to predict the outcome, he will again need the data. Now, the data again cannot be something that has errors, something that has missing values. It has to be perfect, right? Or at least reach the target value, which can be used for analysis, correct? So now the data scientist, if he has to train an AI model or has to build a model, deploy a model, it will still need some tools. Okay, we'll still need to use some tools to perform that, like probably use like on Azure. Again, if I take the example of Azure, we have Microsoft Foundry, which is a data analysis, sorry, it's a AI powered platform. It's a platform for doing all things related to AI. We have Azure ML Studio. Likewise, on AWS, you have different this thing. On GCP, you have the normal Python coding also that you can use in order to work with AI models, right? You can use the different AI models also, and you can work with it, correct? So now what is happening? Every role is using different tools, right? Now, every role can use, probably they can use the same cloud like Azure, okay, and use the different tools, or they can use tools from different vendors. It could be Amazon, it could be GCP, it could be Snowflake, it could be anything, or it could be another data warehouse, or it could be Excel, okay, it could be a database, it could be any tool that anyone can use. Now let's consider one cloud over here, that is Microsoft Azure. Okay, so in Azure, we have so many data related services. We have Azure Data Factory, right? We have Azure Synapse Analytics. We have Azure Databricks service. We have services to store the data like blob storage, data lake. Then we have Azure SQL database. If I want to manage NoSQL data, and for NoSQL data, we all know we have the Azure Cosmos DB, right? If I want to work with real-time data, which is our topic for today, which we are going to see, if I want to handle real-time data, then for real-time analysis, we have again, a different storage, which is called as Azure Data Explorer. And if I have to manage real-time data, again, tools for it on Azure is different. We have something called as Azure IoT Hub. We have something called as Azure Stream Analytics that we need to use, okay? Or if you have to do real-time analysis, you will be using. Now, okay, they are on one cloud, not a problem, everything is fine. But then why Fabric? Like similarly, if you use AWS, so whatever services I listed down on Azure, you will find some service related to that service on AWS or on GCP as well. right? But then why Fabric? Why Microsoft thought that it needs a tool, needs a service like a Fabric, right? So over here, all these tools that I listed down, okay, all these tools that I listed down, they are all platform as a service, okay, which is called as PaaS. Okay, they are all platform as a service. Now, what do I mean by platform as a service? Whenever we use these tools in building our analytical solution, okay, whenever we use these plat platforms, okay, they are all of these in my analytical solution when I'm using, okay, they have to be created individually, or rather I would say all of them have their independent platform that gets created. So let's consider an example. Let's say I have to my data is stored in blob storage, okay, so generally in blob, okay, blob. So blob stands for binary large object, right? So in a blob storage, we generally have data which is saved as files. Now it could be any kind of file. It could be a CSV file. It could be a JSON file. It could be a audio, video file, images file. Okay, it could be it could even be a binary file like ORC, Avro, or it could be a pair key file like a optimized file. Okay, it could be any type of file, and we can save those files either in a blob storage, or we can do the same thing in a data lake on Azure. Okay, so that is what is basically the data lake storage or the blob storage. Now let's say my data is in that in any one of the storages here. Now, from this storage, let's say I want to visualize the data, or let's say, because we are talking about real-time analysis, so I'll try and stick to that example only here. So let's say from my, I have different sensors which are capturing, let's say, real-time data. Let's say it's a temperature sensor, and it is monitoring the temperature every minute, every second, and letting us know what the temperature is of the room or whatever you're monitoring. So over here, let's say the data that I'm getting from the sensor, I want to visualize it on Power BI. Okay, just taking a simple analysis over here. Now let's talk about this implementation before Microsoft Fabric. Okay, and let's involve the Azure cloud only. So I'm going to stick to that cloud only over here. So let's say I want to get the data from the sensors, right? And from the sensors, I want to display it on the Power BI desktop. I want to create a report out of this. So from the sensor, I will have to get the data. So what do I do in order to get the data? Okay, the first step is I need to extract the data from the sensors. I need to extract the data, right? That is going to be the first step that we need to perform. So when I extract the data, now that somebody has to help me, somebody has to help me in getting the data from those sources, extracting the data from the sources. So let's say because it's a real-time source, we have a tool or service on Azure, which is called as the IoT Hub. Okay, it is called as the IoT Hub. Now this hub will help us to basically extract the data from the real-time sensor or the temperature sensor in our case. So one service I created is a IoT Hub. Now I told you it's a platform as a service, meaning what? When we create this service, a separate platform for this service is created on the Azure cloud. Okay. Now from this service, I get the data. Now this data needs to be stored somewhere. I need to either do ETL or ELT, right? Because the data we know is never clean. We need to make it clean, transform it somewhere. I need to perform transformations. So because IoT Hub is just like I would say it's just something that doesn't store the data. Its job is just to extract the data. So now if I have to store the data, I will have to do that either in the blob storage or in the data lake in the form of a file. Okay, in the form of a file, I need to store the data. So let's say I need another service, that is the blob storage. Now what happens over here? Again, another platform for the blob storage gets created, right? Another platform is going to be created for the blob storage. Now from the blob storage, like I said, I want to publish it to, or I want to use the Power BI service. But let's say I want to do the cleaning and transforming. Let's say I'm doing ELT. So before it goes to Power BI, let's say I want to clean and transform the data. It is in the form of file. Let's say I want to make it to tables or change it, something. We want to do the transformation. So let's say I need another tool to do that. So let's say I use something called as the Azure Databricks. Okay, I use something called as the Azure Databricks service. So now what happens? Another service has come in. Now this service also is not is going to be platform as a service. Platform as a service meaning what, guys? You are getting the platform ready. Okay, you're getting the platform ready for that particular service. And every service on Azure, if you see, is platform as a service, except VMs, okay, except virtual machines, every service. Meaning what? In platform as a service, what do I mean by this? You don't have to worry about the infrastructure. Okay, you don't have to worry about the infrastructure. Azure takes care of the infrastructure, the physical infrastructure. But what sort of application you want, where the application you want to create, what name do you want to give, okay, to this application, or application meaning service, okay, over here, what should be the region where you want to deploy it, what should be, where should you save this, what should be the workspace name, okay, so all these credentials you need to sort of give it whenever you're building these services. So like if I show you an example, okay, I've already, I have my Azure cloud open here, so let me show you that example. So let's say you want to build a Azure Databricks service. So if you search for the Azure Databricks service, click on the create button. Can you see that we need to configure this service? We need to create this service over here, right? We need to give a resource group. We need to give a workspace name. What is a workspace? A workspace is nothing but where you save your work. Okay, store your work. That is what is the workspace name. You need to give a region. Another details like you need to configure is the compute. How much compute do you require, right? All those details you need to mention over here. What should be the size of the compute? Okay, what should be, should it have a VPN and everything? All of those things you need to configure on this service. You need to get the platform ready. Okay, you specify this many details. Rest all Azure will take care of, right? Rest all of it Azure will take care of. So now let's say you're using multiple services. Like I mentioned, you're using IoT Hub, you're using Data Factory, let's say. So if you go to the Data Factory service, you click on the create button. Can you see you have to set this service again? Give it a resource group, give it a region, give it a name, which is the workspace name where you want the work to be stored. What name do you want to give? So what happens, because all of these are platform as a service, you have to get the platform ready. Whichever service you want to use, whether you use Azure Synapse Analytics, okay, whether you want to use the blob storage also. So if I click on the create button here, you will see I have to set this service up whenever you want to use it. Okay, so if you go to even the storage accounts, you will see that you have to get the storage ready that you want to use. Okay, you will have to get the storage ready here. So if I want, you will have to create a storage account first. Okay, all those things you will have to configure and etc. So for how many service are you going to do it? Okay, because when you talk about an analytical solution, you're not just using one service, right? You're using multiple services, and those services that you're using, just give me a minute. I'm just looking for a diagram. Yeah. So now this services that you're using, it's not just going to be one service that you're using. There are multiple services that you will be using, and you will be integrating those together. You will be interlinking those services with one another because you have to build and complete an entire analytical solution you want to build, right? Right from extracting the data, transforming the data, loading the data, creating visuals, training an AI model, you have to perform, right? So you can't just only one tool will never help you. You need to take help of different tools to do that for you, right? So you might need, like I told you, when you need IoT Hub to extract the data from the real-time sources, you will need um, to store the data. So probably use a data lake, use a blob storage, right? Or use Synapse Analytics to extract the data. Use Data Factory if it's a batch processing that you are doing. You might have to use Data Factory or Synapse Analytics, right? And now if you have to visualize, so you will use Power BI. If you have to train an AI model, you will use the Azure ML Studio or Microsoft Foundry, and then it will reach the end user. So you're going to use multiple services, and all these services are platform as a service. So everything what is happening now is fragmented. It's scattered. And not just that, another very important thing that we also need to know is, see, we are working with data, right? We are giving out our personal information we are using in order to build that analytical solution. So of course, we need to protect the data also. We need to secure the data. So for that, we need different tools, correct? We need to use different tools to just protect the data. Also ensure, are we governing the data or not? Is governance also is being taken care or not? That also we need to look at. That also we need to manage here. So not just that. Now, at any given time, let's say the data, at some point, a particular service fails, is not working, is not up to date, is crashed, or etc. So what do we need to do? We need to monitor those services, see where the error occurred, monitor the logs. So what happens in these scenarios? You're not just building the services for analysis, but you're also taking care of the rest of the things: security, identity and access, monitoring the services, right? And on any cloud, if you go, all these services don't cost the same. Their cost is different from one another, right? So whatever, let's say you're using the IoT Hub or you're using Databricks, they don't have the same cost. So how do you even manage the cost? Now, forget about that. Another challenge, okay, first challenge we spoke is integration. How can I integrate one service with the other? If I have 10 different platforms for 10 different services, how do I ensure that the data goes from one service to the other? It is not easy. Creating the service is still one thing, but integrating them is something that is not easy at all. It is time consuming. Not just that, now the cost. How do you manage that? How do you manage security? How do you manage the governance? Where, which service is using which? Now, let's say you have multiple departments in your enterprise. Now, which department has to use what sort of services? So we need to govern the data, create a map for it. How do I know that? So we need to map the data. We need to sort of organize the data, structure it, right? The different tools that we are using. Now, not just that. Now, let's say I want to scale this application. Okay, I want to scale, and forget that. Even scaling, which is also another challenge. Not just that, even collaboration. I told you all the data analysis is a collective effort. It's not a one-person job. We have data engineers, data scientists, data analysts to come together, right? So if I want them to collaborate, because here what is happening, all the services are on different platforms. So how do I bring them together also? How do I tell them to collaborate on the analytical solution that we are building? So that is also a challenge because everything's fragmented, everything is scattered. So integration, collaboration, scalability, handling of the cost is also is difficult when everything is on a different platform, right? So not just that, another very important thing is, let's say, even if you, let's say, spend time in building these services, okay, you build them, you're ready to integrate them. No matter how much time it takes, you're ready for that. Okay. But how do I'm sorry, yeah. Now, like I told you, for every service, you need to create a compute. So what is a compute? Compute is nothing but that physical resource that you require. See, because until and unless you don't have a physical resource, how are you going to see the output? Right? You need to see the output also. So who's going to show you the output? Here also now, when you work on your local system, you're using any application, whether it is Word, Excel, or it is PPT, whatever you're using, all of it, don't you think requires physical compute? Your memory, your cores, RAM, ROM, all of those things get involved, and then you are seeing the output, right? Now, same thing when you're working with the data, doing analysis on top of it, whether you're cleaning the data, transforming the data, building the report, training an AI model, don't you think you will require compute? Okay. Now, analysis, when we do, it can be done in various ways. When you are working on databases or data warehouses, okay? So normally the language that is used, the medium through which you do the communication is SQL, right? Structured query language is SQL, right? It is something that is used to analyze the data in the database, data warehouses. When we talk about data in the files, probably CSV file, JSON file, parquet file, whichever file format you want to consider, you normally use a coding language, or coding is the medium through which you are analyzing the data, right? Through which you are analyzing the data over here. Or let's say you want to build reports. You're comfortable with visualizing the data, or you are comfortable by writing or training an AI model. So SQL, a coding language, okay, writing these commands, what are they? They are nothing but mediums through which you are analyzing the data. Now, whenever you use these mediums to analyze the data, you need a compute also, because when you write a SQL command, somebody has to give you the output, somebody has to give you the command output to you, show it to you. Likewise, when you write a Python code also, the Python code has to execute and the output has to come to you. So now what happens, or what is the challenge also, is that depending upon the analysis that you're using, whether it's a Python code or it's a SQL command or etc., any other analysis you're using, okay, you need a compute specific to that. Now, let's say I'm using data warehouse. I'm using data warehouse and I'm writing SQL commands. So when I'm creating a data warehouse, I need to use the SQL engine, because if the SQL engine is not there, okay, I will not be able to get the result. Likewise, if I'm storing the data in a data lake, so with a data lake, normally we need something called as the Apache Spark engine. Okay, it's a big data engine that is used. Okay, it's a very popular engine, basically used with data lakes, lake houses, etc. Right? So this engine, if I have to use, so I need that engine, I need that compute, without which I can't get the output only. So now what happens earlier, because of these things, okay, we had to create separate computes accordingly. Like for big data analysis, if my data is in the data lake or in the blob storage, I want to write a Python code, I need a Spark engine. If the data is in a database, data warehouse, I need to write SQL commands, so I need a SQL engine. Likewise, if I want to work with real-time data, so for that also I need a different engine, right? So those things, now I need these computes to do that specific task, that engine to do the specific task. So what happens over here? We need to again spend time in creating that compute. How many computes are you going to sit and create? My job is to get faster deployment of the analytical solution. If all of this is going to take time for me, right, then we'll want to or we can't wait, right? We can't wait for the for the development team to build this. First of all, you're spending time in creating the engine, creating the service. Then on that service, you have to create the compute. Depending upon your analysis, you need to create that compute, right? So how much time are you going to spend? Do you have that much cost? Do you have that much budget? Forget that. Then you have to do integration. Also decide upon the scalability. How are you going to scale the application, right? So over here, this is what Microsoft identified, and it said, see, I don't want my customers to spend time on this. I don't want them to do this. Everything is fragmented, it's scattered across different vendors. I don't want them to spend time on this. Rather, let me give them a solution that has everything integrated on one platform. Okay, let's bring all the data services and not just from one vendor, that is Microsoft. Let's collaborate with other vendors also, or probably AWS, GCP, whatever that is there. Let's bring that also together so that now what will happen when the teams come together, whether it's a data engineer, data analyst, scientist, sorry, they can use the same space, right? They can use the same space and they can collaborate. And not just that, let me give them scalability also. Okay. And that service, because everything, like I said, the analytics is scattered, is fragmented. So we need to bring them together, right? We need to get all of them together so that you save time in, first of all, integration. Don't have to worry about the scalability. Don't even have to worry about creating compute. Okay, you don't have to even worry about creating the compute specific to that analysis that you are doing. Okay, so such a service that Microsoft came up is called as the Microsoft Fabric platform. So what did they do, or what did Microsoft think? Okay, they said all of them are platform as a service. You name the service, like you have the data factory service, you have the Synapse service, etc. All of them, you have them as the Okay, so you have all of these as the service, which are platform as a service. Let's do one thing. Let's not offer people this as a platform as a service. Let's bring everything together. Okay. Yeah. So let's bring everything together on a single unified platform, and that platform that they call. Okay, so instead of giving everything as a platform as a service, what did Microsoft do? They SaaSified all of this. Okay, they SaaSified all these services onto a single platform, and that is called as Microsoft Fabric. So you want your team, an entire data team to come together, whether it's a data engineer, data scientist, or an analyst. Not a problem. Come, collaborate here on this platform. Okay, so here you will find everything integrated onto one platform. And not just that, now, because we all know we are in the AI revolution, right? Everything is sort of AI is getting incorporated. So even Fabric platform is also leaning towards that, is quickly moving towards that. So it's not just offering solutions to build a complete analytical solution, but also how to use AI in building that analytical solution. So through this Fabric IQ, okay, this IQ component that we are seeing here, it is adding meaning to your analysis. Okay, it is adding meaning to your analysis. So what is Microsoft Fabric? Microsoft Fabric is a unified SaaS platform that brings together data engineering, data warehousing, data real-time intelligence, data science, and business intelligence into a single product. So unlike the traditional approaches where the organizations are stitching together, like I said, integration, stitching together services from multiple vendors, what is Microsoft Fabric doing? It is giving you one integrated platform experience. Okay, one experience where everything you find, right from the data services, and one governance, one storage also, Okay, one place to store the data also. Okay, and billing and everything is now unified. So basically, how does the fabric work? It runs on something called as a capacity-based model. So actually, if I have to put it honestly, guys, what is exactly Microsoft Fabric? So think of it as if it is Microsoft 365. I'm pretty sure everyone knows M365, right? We all use also M365 in a way, that is Word, Excel, PPT, Outlook, Teams, right? M365, these are the products of M365, right? Now let's say these M365, um, this entire concept of M365 that we have is applied to the data services. Okay, exact same thing you have for the organization related or file and document related thing that you have. Just think it is applied on top of the data services. So earlier we had the PaaS services. Now just think they have been SaaSified. So it's exactly, okay, if I have to really tell you what exactly Fabric is, it's just M365, but for data services. In M365, we have all related to file documents. Here, it is everything is related to the data services. Exact same thing. Like in M365 also, if I have to use, we need a license, right? E3, E5, those kind of licenses, without which we cannot use the products within the M365 service. Same thing, it is applied to Fabric, but they don't call it as a license. They call it as a capacity. Okay, it is called as a capacity. So capacity is just that you have, it's like a license that you have to purchase, where you will get the compute, which will be shared. Okay, so now, like I told you, one of the challenges is that we have to create compute for every service, which this particular capacity model eliminates. So I don't have to sit and create a compute specifically for SQL, specifically to do big data analysis or use or analyze the data in the lakehouse or the data lake. I don't have to create a separate compute. All I do is purchase this capacity and I get it in one this thing. Okay, so this is what is the capacity based model that is used by Fabric. Just give me a minute, guys. Yeah. So this is what exactly is Microsoft Fabric, right? Now, how does the Fabric architecture look like? So, like I said, basically it is a SaaS platform. It's like exactly like your M365. Okay, it looks exactly like that. So you use this platform where you find everything, all the analytical tools in one environment, and you pay according to the capacity. Okay, you pay according to the capacity. So that is, so this is the infrastructure. So now if the data team has to collaborate, so now they can use these tools in one platform only in Fabric. So if they want to work with data engineering, so data factory, data warehousing, real-time intelligence that we are going to see, everything is in one platform, right? So all of them can come together now. It eliminates role silos or silos also. Silos meaning isolation. Okay, where people work in isolation, that is called as silos. Okay, so it completely eliminates that, and all the entire data team can come together and collaborate. Now, one such very important thing that you also need to know in Fabric, okay, is called as the one lake. Now, what exactly is one lake? Let's understand that. It's a very simple concept, not at all difficult. Like in M365, if you've ever worked, we have something called as the OneDrive, right? We have something called as the OneDrive. So what does OneDrive do basically? Whatever documents, whatever files you have, right, on the M365 that you have created, whether it's Word, Excel, PPT, right, all your mails, all your recording, videos, audios, whatever you have recorded using the M365 applications, they all get saved in the cloud, and that is called as OneDrive, right? And now when you store anything on the OneDrive, it's not necessary that it gets stored only, or it doesn't store, let's say, PPT file or Excel file. All possible files or documents, even PDFs or something, you can upload in the OneDrive, right? Same thing is also used in Microsoft Fabric. So Microsoft Fabric has got all those services together, right? But what are we basically handling? Or what is this tool basically for? It's a data analytical, data management tool, right? So your data also needs to be stored somewhere, right? Now, the same thing that we discussed for the services, where every service has its own platform. So it is leading to problems. So what does OneLake do? OneLake also eliminates the same problem, that is data silos, where you have independent storages. Okay, let's say some of y'all are using data lake, some of y'all are using data warehouse to store the data. So instead of that, okay, where independent storages are being used, Microsoft Fabric said, see, I don't want my customers again to do that. Okay, just give me a minute, everyone. So over here, we have all these storages now. Microsoft says, see, I don't want people to even manage multiple storages. Okay, let's unify the storages also. And that unified storage, like how you have an M365, which is OneDrive, and this OneDrive accepts anything, right? A Word file, Excel file, PPT file, right? So same thing you can do with OneLake. No matter what type of data you have, okay, whether it's a structured data, semi-structured data, or unstructured data, and you store it probably using the lakehouse. Or now in today's session, what we are going to see is the real-time intelligence. So it is okay. I mean, in real-time intelligence, if I want to work with, or I want to work with lakehouses or warehouses, or work with Power BI, which is the semantic model, or work with databases, work with NoSQL database, that is the Cosmos DB. All of those storages, I can now have it stored in one place, which is called as the OneLake. So it doesn't matter what data you're working with, I will always get it available in OneLake. So it's a unified single storage for your data, like how you have OneDrive, exactly the same thing, but think for it in terms of the data. And that is what is OneLake. So always remember, whenever you use the Fabric service, you will always get the OneLake. So whatever you build on Fabric, it will be stored in the OneLake in terms of the storage. Okay, I'm talking in terms of the storage. So it will be stored in the OneLake. Now let's go ahead and start off. Okay, how can you go access the Fabric platform? How does it look like? Okay, how do you get started with the Fabric platform? So let's understand that here, and then we will quickly move on to the real-time intelligence, right? How you can implement a real-time intelligence solution on the Fabric platform. So before we understand that, we will be understanding certain terms related to it. And then, of course, we will see a demo on the real-time intelligence. So now let's go ahead and see how to build or how to get started with the Fabric service. So guys, Fabric is basically a SaaS application. Like I said, it's a SaaS service. So Microsoft, of course, everything's going to be online here, like your M365, though you do have desktop applications, but there's nothing yet that has come for the Fabric that we can use on the desktop yet. Okay, all the services I'm meaning, there is nothing that has been launched that can be used on the desktop. Everything's put on the cloud. So here, if you have to use the Fabric service, Microsoft has created an endpoint or URL where you can directly navigate to the Fabric service. Okay, so here I'm going to enter the URL, which is called as app.fabric.microsoft.com. Okay, this is the endpoint that you will be using if you have to work with Fabric. Now, guys, when you work with Fabric, okay, please remember this is a solution or a service that Microsoft has created only to cater business related challenges. Now, what do I mean by this? So let's say you're an individual, you're not working or associated with any enterprise. Okay. Then remember, you cannot use the Fabric service. So you have to have a domain name of your enterprise. So you can even read here, it says you have to get started with your organization ID. So you have to be a part of some enterprise or have a domain name of an enterprise with you. Unless you don't have that, okay, you cannot use the Fabric service. Now, another thing after that is, of course, the license. You should have the license to work with the Fabric service. If you don't have the license, you will not be definitely you because the Microsoft Fabric, what has Microsoft actually done? So this has been put in the suite of the products of M365 only, but not everyone in the enterprise can still use the Fabric service. It is a part of the M365 ecosystem only, products that we have like Excel, Word, PPT, but not everyone. Like, for example, Shubh and me, we are both part of the same enterprise, but it's not necessary that Shubh can use the Fabric service. Okay, so not everyone in the enterprise is entitled to use the service. When you get the capacity or the license, yes, then you can start working with the Fabric, but provided, okay, you get the permission to use Fabric. Now, who will give you that permission? So we have an admin, right? How we have an M365 administrator. Similarly, exact same role, but applied to Fabric. There is an admin that is called as the Fabric admin. So he or she has to first of all allocate permission to you, allocate a role to you, okay, and allocate a license based on which you can create, okay, or work with the Fabric content. So here, let's go ahead, log into this. So I have the permission and the license. So I'm just going to log in using my official or my organizational ID. So by default, what Microsoft has done, they have sort of incorporated the Fabric service in the existing Power BI service. Okay, so there is Power BI also available. So if you come to the left-hand side corner and if you click on Power BI, okay, this will take you to the Power BI service, the Power BI portal. Okay, so they by default have incorporated that. So don't think that Fabric and Power BI is the same. No, Power BI is completely different. Fabric is completely different. But yes, you can use Power BI in the Fabric service, but you can't do the reverse. So probably if you're thinking like, let's say if you have a Pro or a PPU license, okay, please remember guys, you cannot use the Pro or the PPU license and work with Fabric content. No. If you have a Power BI Pro or a PPU license, you can only work with Power BI content. But yes, if you have a Fabric license or a Fabric capacity, you can certainly work with Power BI on it. And not just that, but also the other content you can work with it. Now, whenever you start, so let's say you've logged in into the Fabric service, the very first thing that you need to do is create something called as a workspace. Now, what is a workspace? So here on the left-hand side corner, you will find the workspaces. So just click on that and create a new workspace. So just click on this and create a workspace here. So I'm going to give it a name. Okay, so I'm just giving it a name because we are working on the real-time intelligence. So webinar that we are conducting. And over here, if you see, we need to give it a license. So I have a Fabric license that I'm going to allocate to this workspace. Okay, so once you enter all these things, just click on the apply button and you will now see a workspace has been created here. Okay, and next to this workspace, you will see you have this diamond symbol. So this diamond symbols basically indicates that this is a Fabric service. Okay, this is a Fabric or a workspace, sorry, which is capable of managing the Fabric content. Okay. So now let's go ahead and see how to implement the real-time intelligence. But before we go ahead and see that, let's understand certain concepts of the real-time intelligence in Fabric. Okay, what are the components? What are the different things involved in the real-time intelligence? Let's understand that first over here. So let me just share the screen for that. So when you work with the real-time intelligence, so first of all, what is real-time intelligence? Let's understand that here. So real-time intelligence is nothing but, see, when you are working with the data, now data is not, it's not something that can always be stored in a database or in a file as a table or as a file, right? It will always be, it can also stream, meaning it can come in real time, like when we talk about monitoring the temperature or stock prices. Now that temperature or the stock prices we know constantly changes, and it happens in real time, right? Those changes happen in real time. I don't know what will happen when it can suddenly rain or it cannot rain. The temperature can either go up or down. It could be anything. We really don't know, right? So in that case, okay, then we need to even monitor that data. Like, let's say you are doing a live stream and you want to see what comments have come, what sort of comments have been added by people, how many people are viewing the live stream, right? All those things, if I want to monitor in real time so that I can build a content related to that and etc., then that sort of intelligence, that sort of analysis is called as the real-time intelligence. Why? Because I am monitoring that data, analyzing the data there and there, right? So if I want to take quick decisions, like for example, if the temperature has gone down, you are, let's say, transporting a medicinal package, right? Let's say it's something that needs to be transported in a temperature controlled room or in a temperature controlled van or whatever. So I need to constantly monitor the temperature. So let's say the temperature cannot go beyond 20 degrees centigrade, or the ideal range of the temperature should be between 20 degree and 33 degrees centigrade. Or let's say your stock prices that are there, they keep on changing. So let's say suddenly the stock prices have gone up and you want to take a call, you want to take a decision where to invest, where not to invest. So that sort of analysis that you are doing, it has to be done immediately in that moment, in that at that time, right? That is called as the real-time intelligence. Okay, so something that you want to monitor, something that you want to analyze there and there in that time duration is called as the real-time intelligence. So in order to do the real-time intelligence, Microsoft Fabric has a hub. Okay, it has a hub which they call it as the real-time hub. Okay, it's called as the real-time hub. So whenever you want to get started with the real-time intelligence, analyze your real-time data, you can just go to that hub and whatever you need for your real-time intelligence, you will find it here. Okay, so of course, we will see that that's the part of the demo. But before we go ahead and we see the demo, let's understand certain concepts that will be used whenever you work with the real-time intelligence. Now, like I told you, this data is coming in, it is getting ingested in real time. So certainly, if I have to analyze the data, guys, we need to have a medium which is suitable for the real-time intelligence. Okay, a language that communicates to that real-time data. And what is that language called? It is called as the KQL. Okay, what is the full form of KQL? KQL stands for Kusto Query Language. So Kusto is a scientist based on which I don't know what actually is, but this is a Microsoft native language that they have developed, which you can use on any type of data. Now, it could be structured, semi-structured, unstructured data, doesn't matter. Okay, it could be any type of data, but if you want to query it, like how you query the data on a database, same thing. If I want to use it on the real-time data or streaming data, then we use the KQL commands, KQL syntax. Okay, so this is the first thing that you need to know whenever you are analyzing the data in the real-time intelligence. KQL is used. Okay, so KQL is basically designed for searching large-scale data or logs quickly, because it is continuously streaming every minute, every 5 minutes. The data can change. We don't know. So if I want to continuously analyze it, KQL will do that. Okay, so this is the language that is used to query the data and analyze the data. Now, the first thing that you need to know is called as the event house. Now, what is exactly the event house? So this is where actually your data that comes from the different sources is stored and managed. So think of this as if it is an event management company, where the event management company deals with everything related to the event, like catering, decoration, sound systems, arranging the DJ, arranging for logistics, and all those things, right? That need for an event to be successful, all those things that event management company takes care of, right? We don't have to worry. We just have to give them the details. What is the event for? Okay, they will come up with the theme, with the decoration, and all those things. It is their lookout. So same thing. Let's say I want to manage my data that is coming from real-time sources. So this event house will do. All your data, okay, will be managed at a single place, and that is called as the event house. So it's basically, like I said, a management service. Okay, it basically manages your data. Okay, and you can have multiple sources where you are getting multiple databases. Okay, so what kind of databases we have here? It is called as the KQL database, like our SQL database. Similarly, for the real-time intelligence, you have a KQL database. Why KQL? Because this database is compatible with the KQL syntax. So it's no different database, guys. Don't think it's a different database or something. It is a SaaS database, but of Azure Data Explorer. So in Azure, we had this Data Explorer, which is the KQL database, just that it is now SaaSified, but it acts as if it's a database. Just the language that it is compatible with is KQL. Now, this event house will have the database within it. So you can have n number of databases. All the databases, where will they be managed? In this event house. So you have to first of all create an event house, and the minute you create an event house, you will get the database created. Then the next thing that also gets managed within the event house is called as the KQL query set. Now, what is the KQL query set? So KQL query set is nothing but to the database. You will be writing KQL syntaxes, KQL commands in order to analyze the data and etc. Right? So whatever commands you are writing to the database, they will be saved in a notepad sort of thing, like how we use a notebook to keep a note of all whatever is happening in the lecture or something or meeting, right? We make down points, what was discussed and everything. Same thing, whatever you write to the KQL database, all the commands, because here without using the KQL commands, you will not be able to analyze the data. So all the commands are written and stored in this KQL query set. So whenever you create an event house, by default, you will always get the KQL database as well as the query set. Okay. Then the next thing that you need to know is called as the event stream. Now, what is an event stream? Like how we have the data factory service. So data factory is like a low code, no code approach of extracting the data and etc. Loading the data or transforming the data. Basically, it's a ETL tool, right? Same thing is event stream, but for the real-time data. So this gives you like a drag and drop approach, okay, similar to your similar to your data factory, where if you want to extract the data from the sources and load it to a destination without any code or no code at all, then this is what event stream does. So it's like a drag and drop approach that you get. Okay, so this is basically a EL tool. Okay, it's like a EL tool over here. Now, once you have extracted the data, loaded the data, performed the KQL commands you have written, The next thing that you build is also you can visualize this data. Okay, you can visualize this data. And where do you do that? On the real-time dashboard. So real-time dashboard, you can actually create visuals because we all know the power of visualization. So you can use that on the real-time data also and create a dashboard. Okay, so that's the other this thing. And the last thing that you need to know, okay, in your uh, in the real-time intelligence, earlier it was called as reflex, but now it is called as something called as activator. Now, what is an activator? Let's understand that. So activator is nothing but like, because see, this data is coming in real time, right? So we need to constantly monitor it. We need to see, okay, when the temperature went up, when the temperature went down, what is the stock prices today, what is the stock prices yesterday, all those things we need to constantly monitor, right? And let's say suddenly the temperature has gone beyond the threshold, or your stock prices have gone beyond whatever you expected, and you wanted an alert on that. Probably you want to take the next action. Like if the temperature goes up, probably you might want to cool down the temperature. So start an AC, okay, switch on the AC. Or if the stock prices for one bidding has gone up, for one company, it has gone up. So you might want to shift the investment to something else. So if you want to do that, okay, so somebody has to give you an alert for that trigger. Okay, somebody has to, based on an event, has to make you aware about it. And who's going to do that on real-time data? It is this activator service. Okay, so this activator will basically trigger an action to that event. So when the temperature goes up, it's an event. So probably it will send you an email. Stock prices go up, probably send you an email. So that is what activator does over here. Now let's do one thing, guys. Let's use all of these concepts and let's see how I can implement this in the Fabric service. Use the Fabric service to do that, right? So I'm going back to the workspace I created here. Okay, so I'm going back to the service. Okay, so here I'm going to first of all get the data. We need the data. So what we are going to do, we are going to go to the real-time hub. So I don't have any source or so a source. I'm going to use a dummy source to demonstrate this. So I'm going to go to the real-time hub. So if you click on the three dots over here, can you see you're getting a hub which is called as the real-time. So just click on that. And once you click on that, you will see everything, okay, related to the real-time hub. So if you have to get started, all the possible data sources. So these are all the data sources from where you can get all the documentation, case studies, all those things you can get over here. So now let's start off with the data. So I need the data. So I'm going to click on the add data tab. And the minute I do that, can you see that there are different sources from where we can get the data, the different real-time sources. And not just Azure related sources we also have related to the other cloud. Like I said, even other vendors are incorporated or integrated here. Like Google Pub and Sub, you have Amazon Kinesis. Okay. Just give me a minute, guys. Okay, so over here, you can see we have different sources, and it's not just Azure related sources, but you can also get the data from different connectors, different sources. So here, what I'm going to do, I'm going to use a sample source. That is, let's say I want to monitor the stock prices. Okay, stock market data, the bids, prices, volumes. Okay, all those things I want to monitor here. So what we will do, I will use the stock market data. So just click on this. And now over here, can you see we are getting something called as the event stream? So this event stream basically is going to help us extract the data from the source. Okay. So here what we are going to do, we are going to give a name to this event stream. So I'm going to call this as, or the source, I'm going to call it as the stock. Okay. And to the event stream, I'm going to give another name because this is extracting the stock market data. So I'm going to call this as stock data. Okay, this is the name I'm giving. So over here, this is your source. Who's going to get the data from the source? It is the event stream. So we are creating the event stream here basically. Then once you enter all these details, just click on the next button. It's just doing a review and just click on the connect button. So now it is creating a event stream for us, which will basically extract the data from the sources, and just for now, it is just going to do an extraction because we have not configured the destination here. We are going to first of all create the destination, and then we are going to add it to the event stream where the event stream will go and dump the data. So here you can just click on this open event stream and you will see the event stream here. So this is your event stream that is ingesting the data from the stock market, from the stock source. And can you see this is the data? It is giving you the preview here and it's all coming in real time if you see. Okay, but here if you see on the right hand side, it is still not added a destination to dump this or sync this data. So for that, we need to first of all create it. Okay, we need to create that. So what I will do, I'm going to go back to the workspace and we are going to create an event house over here where actually my data, the real-time data that I'm getting is going to be stored, is going to be synced, right? So here, come back to the workspace and just click on the new item. Okay, just click on the new item. Now, what is this item? So in Fabric, whatever you are building, whether it's a lake house, warehouse, pipeline, notebook, event house, event stream, real-time dashboard, okay, KQL database, which is a part of event house only. All of this is termed as an item. So what is an item? Item is nothing but a building block. Okay, it is nothing but a building block over here. So whatever you build, that is called as an item. So if you go to new item, you will see a list of other items and they have been categorized also here. Like if you have to ingest the data, like we have event stream, if you want to store the data, right? So for that also we have sources here. Okay, to store the data like databases, you have event house, semantic model, etc. And if you scroll down, you can see a list of other items also that cater to your data analysis. Okay, so all of this you can find over here. So what we are going to first of all build is an event house. So I'll just search for it. You can even search here for the event house or go to store data and create an event house. So let's call this event house as stock EH. Why this? Because we are dealing with the stock data. So it's better if you name your storage according to what analysis you are doing, right? So here, just click on the create button, create the event house, click on this, and you will see an event house will be created within which you will find a KQL database with the same name has been created. So just click on get started, close this. So can you see here you have a database that is already created. So click on that. And once you click on that, can you see there is a query set also along with the database that we are getting. Okay, so here, now if you expand the database details, you will see currently there is no data, right? Because we have not dumped the data using the event stream. So we need to get the data in the database. Now, if you have to get the data in the database, there are lots of sources from where you can dump the data directly. So if you go to the get data tab here, can you see these are the sources from where you can get the data? Event hubs, you have Amazon S3 also, you can get the data. So probably you have stored the data in any of these sources. You can directly also ingest without using the event stream. You can do that here. Okay, so now because here we are using the event stream, so I'm going to select that. So I have already created the event stream. So just use the existing event stream option. So since everything is in the same workspace, right? So automatically that event stream you will be able to attach it to this. So here now, because this is a database, so we all know in a database, we need a table. Though it is a KQL database, it's still a database, right? So we need to give it a name. So I'm going to call this, so we need to add a table to this where the data is actually going to go. So here, just click on the new table and call this as the stock table. Okay, we are going to call this as the stock table. Select the event stream for where you want to get the data and you want to ingest it. So select the workspace. And in this workspace, we have only one event stream. So select that. And to this, I'm going to give a database connection name. So I'm going to call this as stock data. Okay, this is the name. Oh, sorry, stock table. I'm going to call this as stock table. Okay, so here once you enter these details, so basically from the event stream, now can you see we are configuring the destination, right? So just select, enter all of this, click on the next button, and it will just do a quick schema mapping. Okay, it will quickly map the data to the database. So earlier we had zero data. Now once I click on the finish button, some data will start get ingested, okay, in the table, that is the stock table in the KQL database. So let's just wait for this to complete. Yeah, so this is done. Click on the close button, but we are still not seeing some data. Okay, so let's go back to the event stream and let's check whether the source has been configured or not. So here we need to do a quick refresh of the browser. Then only we will be able to see it. So just refresh your browser and can you see a destination has been added here. So if you click on these details, okay, these lines, you will see what is the source, sorry, the destination, which is nothing but the stock the KQL database that we just created, right? So let's wait for the source to get some data. So you can just keep on refreshing. Let's wait because Eventstream is still dumping the data. So that is why if you go to the database on the top, you will still see zero data or some data has now come in. Yeah, can you see now the data started being ingested into the database, which was earlier zero. Now we have this data here. And can you see a stock table has been created here? Right now, this data will constantly keep on changing as and when the new data starts coming in, you will see the data being updated here. Okay, you will see the data over here. You can even preview the data if you want, though it's not being seen here, but you can see latest data is getting added, right? Now you can certainly query this data, query the captured data using the KQL commands, right? So how do we do that? Go to the table, click on the three dots, okay? And over here, can you see we have one option that is query with code? Okay, you can also use Copilot, everyone. So if you don't know how to write KQL commands, so you can certainly ask Copilot to create. And can you see this is changing constantly, guys? Can you see? Because new data is always getting ingested over here. So now let's query this. So write a KQL command. So here we can directly start by something like this, show any 100 records, and a KQL query will be created. So guys, I'm not going into the details of the KQL command, but this is how it is written. If you see, so the table name comes first, and then if you want to show the data or any other thing you want to analyze, you always write it in the next line. And how is that indicated? By this pipe symbol. Okay, through this pipe symbol, it is indicated over here. Okay, now let's say, now if you see this command, this basically is like show, it's like how we write the select command in SQL, and we are limiting the table to only show us 100 rows. So this is what this command is doing here. Okay, that is what it is being done over here. But now let's say you want to change this. You want to do another analysis. See this data that we are getting. Guys, just give me a second. I'll just sip some water and then we'll continue. Yeah. So over here, now let's say, because this data is constantly changing, it's modifying, as you can see. Let's say in the last 5 minutes, okay, I want to capture I want to see or retrieve the average price for each stock. So here, if you see, we have a symbol column. Okay. So let's say I want to group this symbol column and I want to see what is the average price for every stock or every symbol over here. But in the last 5 minutes. So yes, we can write a KQL query for that. So how it is written? So I'll say stock. And whenever you write a KQL query, the first thing that you mention is the condition, which unlike SQL, where you write it at the end, in KQL, you have to mention your condition first. So what is my condition here? That in the last 5 minutes, I want to retrieve the average price for every symbol, right? Average price I want to calculate. So here, first of all, we will add the condition. So similar to SQL, how we use the where clause, same thing we will do here. That is where, and I will say time. Okay. So there is a time column if you see, because only in the last 5 minutes, I want to retrieve the data. Correct. So here what I will do, I will say, okay, on the time column, please in the last 5 minutes, retrieve whatever is the data. So I'm adding the filter over here. So it has to be greater than 5 minutes. So there is a function that we use in KQL, which is called as ago. So how we say in layman English that 5 days ago, 6 days ago, 1 hour ago, a couple of weeks ago. Same thing you use over here. So you mention that time frame, that how far you want to go behind in time. And for that, you use the function ago. Okay, so over here, what we will do, we will mention that how much time you want to go behind, right? So here for me, it is 5 minutes. You can also say 5 days. So if you have to say days, you will use D. If you have to say hours, use H. If you have to use minutes, just specify M. So here for me, it is 5 minutes. So I'll say 5M. Okay, which will say 5 minutes. This thing will go 5 minutes behind in time. Now, over here, we need to basically group the data, right? We need to group all the symbols, and according to the symbol, I need to calculate the average price. So what we will do, like how in SQL, we have the group by command. Similarly, here also, we have a command which is called as summarize. So summarize is like the grouping condition that you can apply. So here, I want to create a grouping condition. So also along with the group by, we all know we need to give a aggregation function, right? So here I'm going to give an aggregation function, which is to calculate the average price. And in SQL, another thing that we do is give aliases, right? We use the keyword as. So here, if I want to do the same thing, how do we give an alias? It is said, it is something like this. Okay, average price equal to. So it's like how we allocate variable names A equal to 10, B equal to 10. Similarly, here we do that. So here, average price will be the name of the column when I get the result. Okay, when I will get the result, the output. Instead of using average in the bracket bid price, which on top of which I'm going to apply this function, I will get the name of the column as average price. And that is what is an alias. So here we will use the average function. And to this now, by default in KQL, guys, there is no data type that is masked to every column because the data is changing. Okay, it is streaming, it is live. So there is no data type that is masked on the columns. We need to explicitly map it. Whenever we are using this in our calculations, we need to explicitly map it. So here bid price, if you look at the data, is in decimal numbers. It's a decimal value. So here I will use a function which is called as toDecimal. Okay, so what will this do? This will basically map the data type decimal to that column. And which is that column here? For me, it is the bid price column. So it will do an average of the bid price. Okay, and how do I want to group the data? So I will say by and I'll say symbol. Okay, so here this is like a simple grouping operation that we are doing. Just now what we will do, like how in select, we mention which column names I want to show in the result. So similarly, here we will use a KQL command which is called as project. So in the project, you will mention which columns you want to see in your output. Okay, so here I will say symbol, comma, the average price column. And once this is done, just you can see the command is by default selected. And then if you want to see the output, just click on the run button. And can you see here, you're getting a grouping, right? You're grouping the data and you're seeing the output over here. Okay, so this is how, now if you wait for some more time, you refresh the data, you will see that this will change. The average price, the stock, the symbols will change. Okay, so this is how, because it's in real time, so naturally it is going to keep on changing. Now, another thing you can also do is visualize this data on a dashboard. Okay, on a real-time dashboard. Now, remember, whenever you work with the real-time intelligence and you're creating a dashboard, it always depends upon the query that you have written. So your querying, the writing KQL commands is very, very important for your analysis. Okay, so here you will have to write a query and then only you will be able to visualize that query using the dashboard. So here, let's say this query that I have, I want to visualize it. I want to put it to the dashboard. So make sure the query is selected. And can you see on the top, we have this option called as Save to Dashboard. So select that. So here I have no dashboard in my workspace. So I'm going to create one. So just select the new dashboard, give it a name. So I'm going to call this as the stock dashboard. Okay, I'm going to call this as the stock dashboard. Just click on the create button and you will see that using this query, it has pinned a visual to this dashboard. Can you see here? And can you see the data has changed a little bit? If you refresh it again here, you will see that this is changing. Okay, it will keep on changing, of course. Now, let's say you don't like this table. Okay, you want to change this to, let's say, a column chart. And now to this visual, if you see, there is no title that is being given. As of now, I don't know what data it is showing. So let's say you want to add a title. So let's say you want to edit it, format this visual. So what you will do, just hover over the visual and can you see you have the edit option here. Also, one more thing you have to ensure, guys, that this mode that you are currently in is a editing mode. Okay, ensure that this is in editing mode. And now go ahead to the visual, click on the edit button. Can you see the query that we had written is coming here? So you can definitely see it's based on the query. So you can also use Copilot and change the query, improve your queries, anything you want. You can do that. For now, I'm not doing it. I'll just close this and I'll go to the visualization because I want to change the visual. So click on the visualization tab. Now, instead of a table, let's say I want to go with a column chart. So you can see we have a list of visuals that you can use here, right? So go ahead, select any visual that you like. And you can also give it a title. So go to the general settings and add a title. So I'm going to call this as average prices. Okay, I'm going to give this as the name to the tile. And then rest of the things you can change. Okay, colors you want to change, whatever you want to do. Okay, X label, Y label, whatever you want to change, you can do that. Now, once this is done, guys, once you have made the changes, just click on the done button here. And can you see you're getting a new visual? You can refresh this. And can you see the stock prices are changing? Also, you can set this to auto refresh. Here I'm manually refreshing, but you can also set it to auto refresh by going to the manage tab. And over here, you have these refresh settings. So can you see you have this option of live refresh? So you can certainly even change that. So it's up to you. You decide how you want to refresh this. Okay. Now, another last thing that you can do, when last small thing I want to show you, and then of course we will be ending the session, is we talked about the activator technology. Okay, guys, just save your work. So on the left hand side, you have the option of saving. So please save your dashboard. So we talked about the activator technology. So what does activator do? It basically triggers actions based on real-time events. So let's say in our case here, okay, suddenly the average stock prices have increased by a specific amount. Okay, have gone up by some XYZ amount. And when it goes up, I want an alert. I want an email, let's say, that, okay, the price have gone up and you want to take an action. So let's say you want an email to be sent to you. So how can we add that alert? Let's see. So on the top, can you see we have this option of add alert? Okay, or you can even see we have the Thunderbolt sign on this tile. So you can do it individually on the visuals that you have added to the dashboard. So just select this. And can you see here, you can set the rule. Okay, you can set the rule that what something happens. Okay, like a condition you need to give that if this condition satisfies, if this event has occurred, please trigger this action. Right? We need to set this up. So where do we set it up? We do that in the rule. Okay, so here just give a rule. So I'm going to say average price by increase by 100. Okay, and you can now, because everything here, if you see, is based on a query, it is running based on a query, right? So this query will be running every 5 minutes. So can you see this is the frequency where the query will be run? Okay, so you can of course change this frequency however you want it, you can configure. Now here we need to add that based on what is the condition? I said average price, whenever it goes up by 100, I want a notification. I want an action, probably an email or a message in the Teams. So I need to check for that condition. So here in the grouping field, we will say, okay, symbol, but when the average price goes up. So here I will say when average price increases. Guys, just give me a second. So increases by, so we need to change the condition here. So I will go to the numeric change because it is increasing by a value. So I'll say increases by and mention the value here. So if you want, you can also mention in terms of percentage. That is your call. Okay, so here I'll say value 100. And now over here, let's say you don't want a message to be sent to you. Let's say you want to send an email. So if you click on the drop down, can you see you have a lot of actions that you can take, okay, in order to implement whenever the trigger occurs. You want this particular action, or whenever that event comes, you want this to happen, right? So here we are going to save this information in a new item, and that item is called as an activator. So here I will say stock price increase activator. Okay, I'm just giving it a name. So so this rule will be running continuously because it's going to monitor the stock prices in real time. So whenever it crosses 100, we need that information, and somewhere this information also needs to be saved. At what point did it come across the average price going up by 100? I want to monitor that. What was the prices before this occurred? So all those things we need to save it somewhere. And where do we do that? In this activator item. So here just click on the create button and a rule is added on top of this visual, right? So let's monitor this. So let's go to the rule. So I'll just close this. And now this rule also, if you go to the workspace, will be saved here. So you can just go to this workspace, to this. I'll just close all of this. Okay. And can you see this rule has been added? So there will be a constant monitoring that will happen. If you see every 5 minutes, the query will be run. The price value will be checked. And the minute it sees, okay, the price has gone up by 100, it will send you a message to the team. So if you want, you can even test it. If you want to test this, so you can have a test condition. So you can say, send me a test action. So you can just click on this and see what is this thing that you're getting, the message that you are getting. So here, if I go to my Teams, okay, if you see my chat here, can you see activator has sent this? Okay, so this is a sample test it has sent me here. Can you see? This is the latest one that I've got. Okay, so this is how it will send you the alert on the Teams message. Of course, you can change this to any other alert that you want. Okay, so this is just an overview, guys. Of course, you will, like, when we do the training of this particular topic, we go in depth, okay, of every component that we just saw, how you can use the dashboard in different way, event stream, event house, what are the KQL commands that you write, that you can write, and what they will give you in return, right? All of this is basically done in the training. Okay, so here this is how you can implement the real-time intelligence in Fabric. So that is it, guys. So if you now